We're going to jump through a couple worksheets here. Relation is a set of points that connects to, usually this could be known as variables, or variables is probably a good common term for it because we're trying to relate two measured objects. So we'll call those variables. When the two variables are connected, we can use a relation or a function to model. We can technically graph. We can algebraically show it. There's many different ways of showing that relationship. So to model the relationship or to graph the relationship, I'm not sure specifically what they're looking for, but those words would work in that sentence, okay? The second thing they're trying to tell you here is relationships and functions can be finite, and a finite function, what that means is there's a certain number of points. So if I have, for instance, just some coordinates, okay? Technically, this is a relation because it doesn't pass the vertical line test. But more importantly, what we're looking at here is it's finite. There's only 4 coordinates here. Another thing that can be finite is we can technically have a line here that ends, okay? And this can technically have a domain to it, which would usually be called finite because I don't think they're looking for you interpolating, which means going into values. Like the number of numbers between 1 and 2 is technically infinite, but we don't really talk about that till higher level math. So I think they would use this as considered to be a finite one, where an infinite relation or function would be maybe a quadratic that goes on forever, those arrows representing, hey, this is going to continue forever, or a root function, which would be a relation because it doesn't pass a vertical line test, but it technically goes to the right forever, so this would be considered an infinite function also. Okay, so that's what they're trying to get at when they talk about these two things. Domain, the set of possible values that blank may have. They're probably talking about x, because we're modeling on a xy coordinate graph, the Cartesian plane. But usually a good way to say this is the independent variable. Ooh, some terrible writing, variable, okay? And we usually use x to model that variable, and the range is a set of possible values that y, or the dependent variable, may have. And the reason they use x and y is because they're really trying to relate it to, x being your horizontal values and y being your vertical values on a graph. But, we might model things using a business function where we use like cost, profit, and revenue, and we don't use the letters x and y. And that's why I think it's important that we talk about the domain usually being associated with the independent variable and the range being associated with the dependent variable, okay? And we usually model y being dependent on x, okay? Finally, the next thing we want to talk about is interval notation. We're going to jump to the next page. This would be interval notation. So when describing the domain and range of a relation, we use, we can use lots of different things. I think they're looking for these exact words here. Interval notation. Now, there are a couple different ways to represent interval notation. This here regards to the set of something. Usually this is known as such that. This is less than. This is, well, I'm going to say LT, less than, and equal to 2. This is greater than, we'll call this GT, and this one would be GT and equal to. Technically, you can have equals. You can technically have not equals. There's quite a few other different symbols we can use in this notation. But what I want to do is I want to just give you an example of interval notation really quickly. And I think in order to do that, I think I can just bring up, can I do my search bar? No, I can't search that way. I want. Okay, we got a whole bunch of definitions, and I brought in a bit of a graph here. It's a little hard to see, so I'll blow it up by writing these two functions here. This one here says y, the red one, is y is equal to 3x minus 2, which is a linear equation. And it has the set of all values between 2 and 5, okay? Now, in Desmos, it accepts this notation, When we would write it, many times what your teacher may ask you to do is to say that x is the element. This is, I guess we could have wrote this too. This means element. X is the element of, and technically this is a very funny symbol to draw. This R here, that represents all real numbers. And for our purposes, I'm not very good at drawing that. Very commonly, we'll just write the letter R, but this means real numbers. And feel free to look up the definition of real numbers, but it's just the idea of absolutely all values. Okay, so right now we've used the variable x, we've used the element of, we use real numbers. We draw a line here, that's the such that. And then this is where the other half of this would come in. We'd say 2 is less than x, and x is less than and equal to 5. Okay, and that represents this function here. I'm going to put 2 circles at the end, because at the end here, one of the circles represents the value of, I'm going to draw over it actually, I got to go, what the heck number does that stop at? 12, 13, I think. So this value here is 5 and 13. This value here happens to be 2 and undefined. And I want to bring that up because that has a lot to do with us using the less than or the less than and equals to. Okay? Less than and equals to means that point when x is equal to 5, because x is domain, exists. That line touches 5, so we have 5 and 13. When we say x is greater than or 2 is less than x and it's not equal to, when we get to the value of 2, the point actually doesn't exist there. Nothing exists there. We just exist just to the right of it. Okay? Think of domain, if you draw it in Desmos, as like vertical lines slicing and stopping our function. Okay? Now, with that being said, I have another function here. Technically, you could call it a relation. We only drew half of it, so we'll call it a function here. But y is equal to the root of x, okay? And normally what happens is this function actually looks like this. It starts at 0 and goes up. I'll do my best to replicate it. And because the square root of a value actually gives you negative values too, it should exist down there. In Desmos, it tried to make this a function. It didn't want it to be a relation, so it didn't draw that part. And if you look here, I gave it a range that was limited. Range deals with y. And you can represent the range of a function too. Technically, our linear equation up there also had a range of y is the element of all real numbers such that, and the range deals with the y values. So if we take a look here, we would say for y is greater than, or 4 is less than y, and y is less than and equal to 13 in this case. So you notice I'm referencing, because that one's undefined here, but it's almost at the number 4. I'm referencing the y values when I talk about range, and I reference these x values when I talk about domain. So for our other function here, notice I only gave it one limitation here. Y is greater than 2. Okay, so I would say that the range here is y is the element of all real numbers such that y is greater than 2. So it doesn't actually touch the number 2. It'd be undefined once again. And the domain here, we look for the x value. The domain of this is x is the element of all real numbers. I'm not going to draw it fancy anymore. Such that x is greater than, and here's the number 4, greater than the number 4. That's how you'd represent the set or interval notation when graphing these things. To the last page here. State the domain and range of the following functions. Okay, so I'm going to do this really quickly here to get through this. Domain, like I said, we look at the x values. Because it's a line, it's continuous. So we say x is the element of all real numbers such that x is between the number 1 and 5. And I'm just going to draw x in the middle here. It's touching. See how it's a filled in circle? That means it's also equal to. And a hollow circle means it's not equal to. So we're just going to use that value there. And we have our domain. Range, we reference the y values. We would say y is the element of all real numbers such that -2 is the smallest one and 3 is the largest. We put the y in the middle, and same concept, because it's a filled in value, we say less than and equal to 3, but greater than -2. Okay. There are no values in any of these, so I don't have a domain and range for them, but that's how you would do actually the domain and range for this function here. Okay.